Alright, this is a recap going over the notes for conditional statements. To start off, we were looking in our book on page 136. We found that a conditional statement is a compound statement, frequently an if-then statement, which has a hypothesis and a conclusion. Our conditional statements are false only when the hypothesis is true and the conclusion is false. We saw that sort of thing with our counterexamples. We've got three different things we can write from our conditional statement, but let's focus on first what the hypothesis is and what a conclusion is. Our hypothesis is generally the phrase, it's the if statement. It's whatever follows the phrase if. It rains would be just a statement by itself. And we would call that P. If it rains would be part of the hypothesis. It rains is the hypothesis. It's following the phrase or the word if. Our hypothesis is generally given the letter P to indicate something. Our hypothesis doesn't have to be always it rains. It could be x equals 3. It could be the sky is blue. It's just any sort of sentence here. And you're placing the word if in front of it, making it the hypothesis. The conclusion is the then part of a statement. Then the parade is canceled. Again, the parade is canceled is a sentence all by itself. That statement, the conclusion, is often referred to with the letter Q. Hypothesis gets the letter P, conclusion gets the letter Q. The conclusion always follows the word then. So together, our conditional statement would be, if it rains, then the parade is canceled. And that seems to make sense. If it rains, the parade is going to be canceled. Keeping this hypothesis and conclusion in mind, we've got three different other statements we can write. Our converse, our inverse, and our contrapositive. We're going to start with our converse. You guys read that our converse is just the swap of the hypothesis and conclusion. We'd say, if the parade is canceled, then it rains. Notice if and then are always in the same order, but the statements following them are swapped. We had, if it rains, then the parade is canceled. Now we've got, if the parade is canceled, which was Q, then it rains, P. Our converse swaps our P's and Q's. Now, in this case, you can think, this sounds weird, it sounds strange, and you're right. This statement is implying that if the parade is canceled, it rains. That the parade being canceled makes it rain. That would be a false statement. We can put the letter F over here for false. Then we have the inverse. The inverse takes our original hypothesis and conclusion and negates them. Puts the word not in it somewhere. If it doesn't rain, then the parade isn't canceled. As opposed to, if it rains or if it does rain, then the parade is canceled. If it doesn't rain, the parade isn't canceled. Now, our inverse, you might think, well, this makes sense. If it doesn't rain, then the parade isn't canceled. But can we come up with counterexamples where even if it doesn't rain, the parade might be canceled? Sure. Just because it doesn't rain doesn't mean the parade isn't canceled. It could be that there's a blizzard. It could be that there's a flood. There are plenty of things where it doesn't rain, but the parade could still be canceled. So this could still be a false statement. Our contrapositive is a mix of the converse and the inverse. We're going to swap and negate the hypothesis and conclusion. If the parade isn't canceled, then it doesn't rain. And that makes sense. If the parade isn't canceled, it's not raining. They were going to cancel. If it rains, the parade is going to be canceled. If the parade isn't canceled, it means it isn't raining. This we'd consider to be a true statement in this case. This true statement sort of matches the original hypothesis conclusion in that the original statement of if it rains, then the parade is canceled would be true probably as well. Alright. We're going to see this with one example. We're going to see with number 1. You had 6 questions. 1, 2, 3. Question 4. Question 5. And question 6. We're going to do question 1 together super quickly. A 3 points lie on a line, then they are collinear. We just want to identify the hypothesis and conclusions. We want to identify the converse, the inverse, and the contrapositive. Your hypothesis follows the phrase if. So our hypothesis is 3 points lie on a line. A statement by itself. 3 points lie on a line. 3 birds lie on a line. 3 things are on the same line. The conclusion is what follows the word then. You see they are collinear. We could specify that 3 points are collinear. We don't need to ever keep it exactly the same. If you want to be clear about what they is the 3 points. Now that we've identified our hypothesis and our conclusion, our P and our Q, our converse is going to be swapping them. If Q, then P. If 3 points are collinear. Then they lie on a line. Last statement would be the converse. We've got our Q here, 3 points are collinear. They lie on a line, that's P, our hypothesis statement originally. And our inverse of the original statement is if not P, then not Q. The little tilde in front of the P and Q means not, or the opposite of. Again, it's just putting the word not or don't somewhere in the sentence. If 3 points don't lie on a line, then they aren't collinear. It's the same statement as our hypothesis and conclusion. We were just putting the word not in a regional spot. So they are became they aren't. 3 points lie or do lie on a line. They don't lie on a line. Last thing is our contrapositive, where we take our converse and negate it. If not Q, then not P. We're going to take our conclusion, our Q, and make it negative, and it'll be the first phrase after the if. If 3 points are not collinear. Then we want our P statement, and we want to make it negative. Then 3 points do not lie on a line. Then they don't lie on a line. We have our hypothesis and conclusion. We have the converse, the inverse, and the contrapositive. You have the remaining problems to finish up. We did plenty of these in class today.